Hi students, in this lecture we will see an important theorem related to 1-1 and kernel of a function, 1-1 function and kernel of a linear transformation. A linear transformation T from U to phi is 1-1 or injective if and only if kernel of T is equal to 0, where U and V are vector spaces over the field F. F may be a set of real numbers R. Suppose T is 1-1. First part, direct part, suppose T is 1-1. We have to show that kernel of T is equal to 0. For that, let U belongs to kernel of T be any vector. We have to show that this vector U is 0. So this implies that T of U equal to 0 by definition of the kernel of T. This implies that T of U equal to T of 0 because T of 0 equal to 0 as T is a linear transformation. This implies that since this T is a 1-1, so this implies that U is equal to 0. Any vector U belongs to kernel of T. This is any vector and this value is 0. So kernel of T must be 0. Now we are going to see the converse part of this theorem. This is a very easy theorem. Converse part of this theorem. Conversely, suppose that what we have to suppose? Kernel of T is equal to 0. We have to prove that T is 1-1. We have to prove that this T is 1-1. So consider T of U1 is equal to T of U2, where U1 comma U2 belongs to U, be any two vectors. This implies that T of U1 equal to T of U2. This implies that T of U1 minus T of U2 equal to 0. Adding minus T of U2 on both sides, we get this. Okay. This implies that as T is a linear transformation, T of U1 minus U2 equal to 0. T of U1 minus U2 equal to 0. And this implies that U1 minus U2 belongs to kernel of T because its image under T is 0. This implies that U1 minus U2 belongs to what is kernel of T? Kernel of T is 0. So this implies that U1 minus U2 equal to 0. This implies that U1 equal to U2. Therefore, T is 1-1 or injective. Therefore, T is 1-1 or injective. Hence the proof. Thank you, students.